Okay, students, we have completed alkanes. Now we'll start alkene. So in alkene also, you have to study about their naming, how to write the name of alkene. Already we have done the nomenclature of alkenes. So, and you have to know about the methods of preparation of alkenes, how to prepare the alkenes in laboratory, and what type of reactions shown by alkene, that you have to study here. So as you know, alkenes are unsaturated hydrocarbon which contain carbon-carbon double bond, and alkene have the Zenel formula CnH2n. This is the Zenel formula of alkene. For example, if you consider C2, hydrogen will be 4. If you consider C3, hydrogen will be 6. If you consider C4, hydrogen will be 8. Like this you will get the molecular formula of alkenes. Here 2 carbon present, that's why it is called ethene. This is called propene. This is called butene. Like this you will get different types of alkene. So alkenes are unsaturated hydrocarbon which contain carbon-carbon double bond, and they have the Zenel formula CnH2n. Since alkene contain double bond between carbon and carbon, that is why minimum 2 carbons should be present in your alkene. That's why alkenes start from ethene. You don't get methane because methane contain only 1 carbon. So you don't get methane. Alkene will start from ethene. I mean it start from 2 carbon. So these are some examples of your alkenes. Now these alkenes are also called olefin. As you have got, your alkenes are also called paraffin due to less reactivity of alkenes, and these alkenes are also called olefins. And why they are called olefins? Because the lower members of alkenes, when they react with halogen means fluorine, chlorine, bromine, iodine, when they react with halogen, they will form some oily product, and that is why alkenes are also called olefins. So alkenes are called paraffins, alkenes are called olefins. Why they are called olefins? Because the lower member of alkenes, when they react with halogens, they form some oily product, and due to formation of this oily product, these alkenes are also called olefins. Now, nomenclature already we have done, how to name the alkenes. Now we will do about the methods of preparation. Methods of preparation of alkenes. I mean, how to prepare the alkenes in the laboratory. Suppose in laboratory ethene is required, but ethene is not available in lab. So you can prepare that ethene from some other compound. If alcohol is present, from alcohol you can prepare alkene, I mean ethene. If ethyne is present, I mean if alkyne is present, you can prepare alkene. So there are a number of methods. I mean from another compound you can prepare the alkenes. So one by one method I will give you. Number 1, which is called by dehydration of alcohol. This is the first method to prepare the alkenes, by dehydration of alcohols. Actually hydration means addition of water, and dehydration means removal of water. So dehydration of alcohol means from alcohol you have to remove water molecule, then the alkene will produce. For example, suppose this is one of the alcohol, RCH2CH2OH. You know the organic compound which contain OH functional group, they are called alcohol. So this is one example of alcohol. Now when this alcohol is treated with concentrated sulfuric acid will act as dehydrating agent. I mean concentrated sulfuric acid can remove the water molecule. So when the alcohol is treated with concentrated sulfuric acid, then one water molecule is released from the alcohol, and you will get the alkene from the alcohol. And how water molecule is removed from this? Since this carbon contain the OH functional group, from this carbon the OH will be released, and from the next carbon, I mean from this carbon, one hydrogen will be released. I mean the OH will release from this carbon, and one hydrogen will release from the next carbon. So that hydrogen and this OH will combine to form water, and when this water is released from the compound, then the remaining compound will be R, then it becomes CH because one hydrogen is released from this carbon, and it becomes CH2 from this carbon, the OH will release, and in between them you will get the double bond, you will get the alkene. So from alcohol you can prepare alkene like this way by doing dehydration. This concentrated sulfuric acid is called dehydrating agent. it can remove water molecule from alcohol like this. For example, this is one of the alcohol, CH3, CH2, OH. There are two carbon here, that's why this alcohol is called ethanol. When ethanol is treated with concentrated sulfuric acid, then dehydration takes place. Since this carbon contains OH, from this carbon your OH will be released, and from the next carbon one hydrogen will be released, and it will produce water. When one hydrogen is released from this carbon, it becomes CH2, and when the OH is released from this carbon, it also remains as CH2, and in between them you will get the double bond, and side product will be water. You will get the ethene. This type of reactions are called elimination reaction, in which the single bond is converted to double bond. Some molecules are eliminated from the compound. Since water molecule is eliminated from the compound, that's why this type of reactions are called elimination reaction. And in elimination reaction, saturated compounds are converted to unsaturated compound. This is one of the alcohol, CH3, CH2, CH2OH, which is called propanol, because 3 carbon present here. This is called propanol. When propanol is treated with concentrated sulfuric acid, then since this carbon contains OH, always OH is released from the carbon, and from the next carbon one hydrogen will be released from the next carbon. So this carbon will remain same, CH3, then this carbon will be CH because one hydrogen will be released from this carbon, and from this carbon OH is released, that's why it remains as CH2, and in between them, from this carbon OH is released, from this carbon hydrogen is released, and from that in between that two carbon you will get the double bond, which is called the elimination reaction, and water molecule is released, you will get the propene. So this is called dehydration of alcohol. By doing dehydration you can prepare the alkene, ethene, propene, butene, any alkene you can prepare. If you require ethene, then ethanol you have to take as reactant. If propene is required, propanol you have to take as reactant. So you can prepare any alkene by using this method. Similarly, this is one of the alcohol. This alcohol is called 1, 2, 3, 4. 4 carbon present, that's why it is called butane 2-ol, because the OH is present in second carbon, that's why it is called butane 2-ol. When this butane 2-ol undergo dehydration in presence of concentrated sulfuric acid, then what happen? From this carbon, since this carbon contains OH, from this carbon the OH will be released, and from the next carbon one hydrogen will be released. Now from this carbon there are two next carbon. You can consider this one as next carbon, this one also next carbon. So you can remove hydrogen from this carbon also, you can remove hydrogen from this carbon also. But if you remove the hydrogen from this carbon, then double bond you will get in this position. And if you remove hydrogen from this carbon, double bond you will get in this position. If double bond is present in this position, it is called but1-ene. And if double bond is present in this position, it is called but2-ene. So there are two possibilities to get the product. You will get but1-ene also, you will get but2-ene also, because hydrogen can remove, you can remove from this carbon also, you can remove hydrogen from this carbon also. That is why in this reaction you will get two products. If you remove the hydrogen from first carbon, from this carbon, then double bond you will get in this position, and you will get the product like this. OH is released from this carbon and hydrogen is released from this carbon. Similarly, if you remove hydrogen from this carbon, you will get another product. The product will be like this. Hydrogen is released from this carbon because both are next carbon. So you can remove from both the carbon. And this is called but1-ene, and this is called but2-ene. And the side product will be water. But in this reaction, you will get butene 80%, butane you will get only 20%. I mean butene is the major product, butane is the minor product. That is why in exam if the question asks write the major product, then you have to write only butene, not the butane. And why butene is major product? Actually there is a rule which is called Seitz-Zaff rule. According to Seitz-Zaff rule, butene is more stable than butane, and that is why due to more stability of butene, that is the major product. So what is Seitz-Zaff rule? This is called Seitz-Zaff rule. According to Seitz-Zaff rule, those alkene in which double bonded carbon contain less number of hydrogen, they are always more stable. Here these two are double bonded carbon. This double bonded carbon contain 2 hydrogen and this double bonded carbon contain 1 hydrogen. I mean there are 3 hydrogen present with the double bonded carbon. And here these two are the double bonded carbon, they contain 2 hydrogen. Those alkene which contain less number of hydrogen with the double bonded carbon, they are always stable according to Seitz-Zaff rule. And that is why butene is more stable than butane, and that is why in this reaction butene is the major product. I mean you will get butene is more, butane you will get less amount. So that is why when you do dehydration in butane 2-ol, then you will get butene as the major product. I mean maximum hydrogen will release from this carbon, not from this, because butene is more stable according to Seitz-Zaff rule. So this is one method of preparation of alkene. You can prepare any alkene by doing this reaction.